One National Weather Service office issued 26 tornado warnings in a single day. That's more than 2 warnings every hour for a full day, all targeting the same corridor of states that's now back under threat. The Storm Prediction Center has already placed that corridor under a new multi-day severe weather outlook. The office that issued those 26 warnings was NWS La Crosse, serving parts of Wisconsin, Minnesota, and Iowa. It happened during the April 13th through 17th outbreak. That single-day total broke the office's own all-time record. No other day in that office's history came close. In the same stretch of days, NWS Green Bay confirmed 10 tornadoes touched down across Wisconsin and Minnesota. Localized rainfall reached 4 inches in concentrated zones along the same corridor. That rainfall didn't drain. It sat on ground that was already full. If you've lived through a tornado outbreak in the Midwest or along the lower Mississippi, we'd ask you to subscribe to the Science Studio, because this is the kind of event we track in real time and close detail. And if you're in one of the states under the new outlook right now, drop a comment and tell us your county and what you're seeing on the ground, because the pattern we're about to walk through doesn't look the same from every state in the corridor. The new outlook from the Storm Prediction Center covers Thursday, April 23rd, and Friday, April 24th. It names eastern Kansas, western Missouri, Oklahoma, Arkansas, northern Louisiana, western Mississippi, and Tennessee. All 3 major severe hazards are confirmed on the outlook for both days. That means tornadoes, damaging winds, and large hail. Thursday's core threat is anchored in eastern Kansas, western Missouri, and southward through Oklahoma. The storms on Thursday form along a cold front pushing down into warm Gulf air. That front doesn't sit still, it moves east overnight. Friday's threat shifts with it. The primary zone on Friday pulls into Arkansas and the Arklatex corridor. Little Rock, Arkansas sits directly inside the Friday zone. Shreveport, Louisiana, and Memphis, Tennessee sit inside it too. 7 states under the same outlook at the same time. That's a stretch of land wider than the drive from New York to Chicago, and it's the same corridor whose rivers haven't drained yet. For anyone in eastern Kansas, western Missouri, Oklahoma, Arkansas, or western Tennessee, the window between the last warning and the next one is shorter than the time it takes a river to come down from flood stage. Rivers across this corridor were confirmed at or near flood stage when the new outlook was issued. The NWS Weather Prediction Center confirmed the cold front arrives late Wednesday night. That timing matters in a way most people miss. The front doesn't arrive in full daylight. It interacts with Gulf moisture overnight, when most residents are asleep, and it begins producing storms before the morning weather check. By the time people in the threat zone open their front doors on Thursday, the first warnings may already be active. Most coverage of the April outbreak reported a single event with a record-breaking day. The actual data showed something different. The Storm Prediction Center had already been watching this corridor as a multi-wave setup. The outlook for the new Thursday and Friday event went up before the damage from the first event was fully assessed. That gap between coverage and data is where the story sits. The named zones on Thursday are eastern Kansas, western Missouri, and Oklahoma. The named zones on Friday are Arkansas, the Arklatex corridor, and western Tennessee. Each of those names is a city on a river that someone watching right now recognizes. Each of those names is also a point on a river that hasn't drained yet. The ground in Wisconsin, Minnesota, and Iowa took 4 inches of rain in localized zones during April 13th through 17th. 4 inches doesn't sound catastrophic to a viewer who has never measured rainfall against soil capacity. It becomes catastrophic when the soil underneath it is already saturated. Saturated soil means every new raindrop runs off the surface instead of soaking in. 4 inches of rain fell on ground that was already full. That single fact is the bridge from the April event into the Thursday event. It's also the reason the Storm Prediction Center's new outlook reads differently than a normal severe weather outlook. The hazard isn't just the storm, it's the ground the storm arrives on. The Weather Prediction Center's confirmation of the cold front's overnight arrival tells you the clock has already started. The outlook names Thursday, the outlook names Friday. The timing is set by the physics of the front, not by the readiness of the people in its path. If you're in one of the named cities, you're looking at a 2-day window with back-to-back threats. If you're upstream of those cities on one of the major river systems, you're looking at water that was already elevated before any of this began. The Storm Prediction Center doesn't issue a multi-day outlook unless the signal is strong. The signal here was strong enough to cover 7 states. The countdown from the moment of the new outlook to the arrival of the front closes in hours, not days. NWS La Crosse and NWS Green Bay, the offices that handled the April 13th through 17th event, aren't the offices that will handle Thursday's core zone. Thursday's zone belongs to NWS Topeka, NWS Kansas City, NWS Norman, and NWS Tulsa. Friday's zone pulls in NWS Little Rock, NWS Shreveport, NWS Memphis, and NWS Jackson. Each of those offices is now coordinating on a shared setup. The Storm Prediction Center holds the broad outlook. The local offices issue the county-level watches and warnings as the front moves through. That coordination works when there's a recovery window between events. When there's no gap between events, the coordination pipeline runs against its own design. 4 inches of rain fell on ground that was already full. The ground was full because NOAA's Climate Prediction Center flagged April 28th and 29th before the Thursday outbreak even begins. That means the agency tracking long-range precipitation risk across the United States has already pointed at a third wave of heavy rainfall potential for the same corridor. The signal was assembled and published before the Thursday front even arrives at the Gulf moisture line. To understand why this corridor keeps getting hit, you have to understand the land itself. The central United States sits inside a geographic funnel. Warm, moist air comes up from the Gulf of Mexico. Cold, dry air pushes down from Canada. Between them, there's no mountain range to slow either one down. The Rocky Mountains sit to the west. The Appalachians sit to the east. Between those two ranges, the land is open. Warm Gulf air flows north through that open channel. Cold Canadian air flows south through the same channel. When they collide, the collision happens over open ground, without any geographic barrier to slow it or break it apart. That collision is what drove the April 13th through 17th event. A cold front pushed south while Gulf moisture surged north. The two air masses met along a frontal boundary that ran through the upper Midwest. The instability along that boundary produced the storm complex that hit Wisconsin, Minnesota, and Iowa. During that event, the Storm Prediction Center's own Day 1 outlooks initially underestimated the geographic scope of what was coming. The forecasters at SPC run the most advanced severe weather models in the world. On the early days of that event, the models didn't fully capture how wide the threat zone would actually become. By the time NWS La Crosse issued its 26 warnings on its worst single day, the numbers exceeded what internal planning thresholds had prepared the office to handle. That's the first signal that something was off in how this system was being modelled. The forecasters weren't wrong about the event happening. They underestimated the footprint. The actual footprint spread wider than the initial outlooks, and the pace of warnings in some offices crossed a line that had never been crossed before in that office's recorded history. The Thursday and Friday event is being driven by a nearly identical mechanism. The NWS Weather Prediction Center has confirmed a cold front pushing into the same moist Gulf air mass. The structure matches the structure that drove April 13th through 17th. The difference is the ground it arrives on. The ground arriving at Thursday is saturated. Rivers in the region are confirmed at or near flood stage. The prior 4-inch rainfall totals haven't drained. Every element of the atmospheric setup is comparable to the April event, and the surface conditions are worse. There's one term weather forecasters use that matters here. It's called a stalled frontal boundary. A normal cold front pushes through a region and exits. A stalled frontal boundary parks over a region and stops moving. When a boundary stalls, it keeps feeding the same storm system with new energy for hours or days. The warm Gulf air keeps pushing into the cold air on the other side of the boundary. The collision keeps producing new thunderstorm cells along the same line. The storm system doesn't dissipate because the fuel never cuts off. The stalled frontal boundary is the compounding factor that neither forecasters nor residents fully anticipated during the April event. The models can forecast a moving front with reasonable accuracy. The models have a harder time forecasting exactly when and where a boundary will stall. When a boundary stalls, the rainfall totals in the zone underneath it climb faster than any single storm forecast suggested. That's what happened in Wisconsin, Minnesota, and Iowa. The boundary didn't move on schedule. The rain kept falling on the same counties. The totals climbed. NOAA's Climate Prediction Center has now confirmed a second stalled frontal boundary is expected to return around April 28th and 29th. That confirmation places a third wave of heavy precipitation potential across the southern plains, the Tennessee Valley, and the lower Mississippi Valley. The same atmospheric pattern that produced the April event and is now producing the Thursday event is expected to reassemble for a third round. You're looking at 3 separate storm waves inside of 16 days. 16 days is roughly the length of a family vacation from start to finish. 3 major severe weather pulses in that window is not a normal pattern. For rivers that are already at or near flood stage, there's no recovery window between Wave 2 and Wave 3. The frontal boundary that drove the April event never fully left the region. The pattern producing these waves isn't three different systems. It's one continuous atmospheric setup that keeps reloading. The frontal boundary that drove April 13th through 17th never fully left the region. That detail is the piece that connects everything. It's also the piece that changes how you should read the Thursday outlook. The Thursday event isn't a new system arriving in a quiet corridor. It's a new pulse inside a pattern that has already been running. The Storm Prediction Center's coverage of that pattern works by layering outlooks. The Day 1 outlook covers the first 24 hours. The Day 2 through 3 outlooks cover the next 2 days. The Day 4 through 8 outlook covers the longer window. NOAA's Climate Prediction Center handles the longer range signal beyond that, out through the weeks 3 and 4 window. Each layer is built by a different forecaster team using different models. When all 4 layers point at the same corridor at once, the signal is strong. In this case, SPC's short-range outlooks and CPC's long-range outlook are aligned on the same geography. That alignment is why the April 28th and 29th flag matters even before Thursday's storms form. For a homeowner in eastern Kansas, the model signal translates into something concrete. The ground under the house is already wet. The river downstream is already high. The next front arrives overnight Wednesday. The front after that arrives Friday. The front after that arrives the following week. The cold front confirmed by NWS WPC for Thursday arrives with the same structure as the April front. The boundary behavior expected to drive the April 28th and 29th event matches the boundary behavior that produced the training storms in the April event. NOAA CPC has already published the risk flag for the third wave. The risk is not hypothetical, it's inside the official long-range outlook. That same outlook, published by NOAA's Climate Prediction Center, shows above normal rainfall likelihood continuing across the southern plains, the Tennessee Valley, and the lower Mississippi Valley through the end of April. That signal was in place before Thursday's storms form. The third wave risk isn't a projection pulled out after Thursday. It was already in print. The infrastructure in the region wasn't designed to handle this loading. Flood control systems have drainage assumptions built into them. The drainage assumptions assume a recovery window between events. When the recovery window is shorter than the drainage time, the system operates outside its design parameters. The rivers confirmed at or near flood stage after the April event are inside their drainage window right now. The Thursday event arrives before that window closes. The April 28th and 29th event arrives before the next drainage window closes. Each event is absorbed on top of the previous one. The forecasters aren't hiding anything. The data is in the public outlooks. The local NWS offices know the pattern. The Storm Prediction Center knows the pattern. NOAA's Climate Prediction Center has written it into the long-range outlook. The piece that's missing in most of the public conversation is the connection between the 3 waves. NOAA's Climate Prediction Center flagged April 28th and 29th before the Thursday outbreak even begins. NWS Green Bay's post-event summary named what happened during April 13th through 17th. They called it training storms. The term sounds routine. It isn't. On dry ground, training storms are a problem. On saturated ground, training storms are a different problem entirely. The ground loses its ability to absorb after the first wave. Every additional storm in the train delivers rainfall that runs off immediately. The Thursday and Friday system features the same training storm potential along the same frontal boundary. The Weather Prediction Center's confirmation of the front's overnight arrival tells you the setup is already in motion. The boundary will interact with Gulf moisture late Wednesday night, and the first storm cells will form along the line as the collision intensifies. The instability across the Thursday threat zone is measured by what forecasters call an instability index. The instability index measures how violently air will rise when it's triggered. A higher number means the air wants to move upward faster and with more force. Violently rising air is the engine of a severe thunderstorm. The instability index across the Thursday zone is elevated. It was elevated before the cold front even arrived. The reason is the prior rainfall. The prior 4 inches of rain in localized zones removed what forecasters call the stabilizing dry layer, the pocket of dry air that normally caps the atmosphere and limits how high storms can build. When that dry layer is gone, the atmosphere becomes more unstable. Storms that do form build higher, produce more rainfall, and generate stronger updrafts. The updraft is the column of rising air inside a thunderstorm, and a stronger updraft produces larger hail and supports tornado formation. The Storm Prediction Center's outlook covers all three hazards on Thursday and Friday, because all three hazards are supported by the instability numbers. The viewer assumes a severe weather threat is a single storm that arrives and passes. Training storms hit the same spot repeatedly, without moving on. During the April event, some counties in Wisconsin received 4 inches of rain, not from one storm but from a chain of cells that kept reforming over the same neighborhoods, like someone refilling a glass that's already overflowing. For residents in the Thursday and Friday threat zone, the danger isn't just the storm that arrives, it's the storm that forms directly behind it in the same location. The instability index across the Thursday zone was already elevated before the cold front even arrived. NWS Green Bay called them training storms. The term is precise. The precision matters because training storms change the threshold for flash flooding. On normal ground with a normal dry layer overhead, a flash flood warning typically needs heavy rainfall in a short window. On saturated ground with a missing dry layer, the threshold drops. Moderate rainfall alone can trigger flash flooding. That's the piece most residents don't factor into their own risk picture. A thunderstorm delivering 1 inch of rainfall on dry absorptive ground is a passing event. The same thunderstorm delivering 1 inch on saturated ground with no drainage capacity is a flash flood event. The storm didn't change, the ground did. The Thursday threat zone includes counties where soil absorption is confirmed at or near field capacity. Field capacity is the technical term for the point where soil cannot hold any more water. Once field capacity is reached, any additional rainfall becomes surface runoff. Surface runoff travels downslope. In the corridor from eastern Kansas through Oklahoma and into Arkansas, downslope leads to tributaries of the Arkansas River, the Mississippi River, and the Red River. Tributaries carry the runoff into the main channels. The main channels are already running high. NWS Green Bay's post-event summary framed the April rainfall totals in terms of duration, not just amount. The 4-inch totals didn't fall in a 30-minute downpour. They fell across hours as successive storm cells passed over the same neighborhoods. The duration of the rainfall is what saturated the ground. Thursday's setup has the same duration risk. The cold front isn't expected to sweep through and exit in 90 minutes. The interaction with Gulf moisture is forecast to extend through Thursday, with Friday's event continuing the pattern along a shifted line. That's not a single storm. It's a system operating over a multi-day window. The Storm Prediction Center's outlook for Friday names Little Rock, Shreveport, and Memphis inside the primary threat zone. Each of those cities sits on or near a river system that is currently elevated. Each of those cities is downstream of counties that received rainfall during the April event. Each of those cities is about to receive new rainfall on top of the existing river levels. For the meteorologist tracking this setup, the instability index, the missing dry layer, the stalled boundary potential, the training storm mechanism, and the saturated soil are 5 different variables all pointing in the same direction. When 5 variables align, the model confidence rises. The Storm Prediction Center didn't place the corridor under a multi-day outlook, because one variable looked concerning. The placement reflects an alignment across the whole picture. In practical terms, the missing dry layer changes the speed of storm development. When the dry capping layer is already gone, storms can organize faster than the standard warning timeline assumes. That affects how much lead time forecasters have to issue warnings. The operational warning process assumes a certain storm development speed. When the storm develops faster, the warning lead time shrinks. NWS offices issue tornado warnings when a storm shows rotation or when a tornado is confirmed on the ground. The typical warning lead time is measured in minutes. When the atmospheric instability is already elevated before the front arrives, the storm's ability to produce a tornado on first rotation is higher, and the lead time available to the forecaster is shorter. That's the operational reality behind the meteorological setup. The models point at a corridor, the forecasters issue the outlook. The local offices prepare for the event. When the event forms inside a preconditioned atmosphere, the time between first radar signature and first warning compresses. For the viewer in the threat zone, the compression translates into fewer minutes between a phone alert and the storm arriving at the door. The compression is a function of the instability index being elevated before the front arrives. The elevation is a function of the prior rainfall having removed the stabilizing dry layer. The prior rainfall is a function of the April 13th through 17th training storms. Each link in that chain is documented. The chain itself is what the Storm Prediction Center and the Weather Prediction Center are watching right now. The dry stabilizing layer that normally limits storm strength is already gone across the Thursday zone. The dry layer is gone because the April event wasn't the end of a pattern. It was the first pulse. Most news coverage treated the April 13th through 17th outbreak as a discrete crisis, something that arrived, broke records, and ended. NOAA's models show a different picture. NOAA's Climate Prediction Center publishes a weeks 3 and 4 outlook. It runs groups of computer model forecasts to project rainfall likelihood over the coming weeks. The current weeks 3 and 4 outlook shows above normal rainfall likelihood continuing across the southern plains, the Tennessee Valley, and the lower Mississippi Valley through the end of April. The outlook was published before the Thursday outbreak even begins. That's the gap between what the coverage ended and what the data kept showing. Most coverage reported the April event as a closed chapter. The actual data shows the chapter was still open when the coverage moved on. The stalled frontal boundary that drove the April event is the same mechanism driving Thursday and Friday. It's the same mechanism expected to drive the April 28th and 29th third wave. This isn't 3 separate events. This is one continuous atmospheric pattern producing waves. The waves are separated by pauses that are too short to count as recovery. The pauses are where the ground is supposed to drain, the rivers are supposed to fall, and the emergency response systems are supposed to reset. The rivers in Wisconsin, Minnesota, Iowa, and the broader central US corridor that rose during the April event haven't come down to normal levels. They're the baseline for what arrives Thursday. Thursday's rainfall will fall on top of river levels that are already elevated. The river response to Thursday's rainfall won't start at 0. It will start where the April event left it. That difference between a severe weather outbreak on dry ground and a severe weather outbreak on flood-stage rivers is the difference between a storm and a compounding disaster. The storm itself produces tornadoes, hail, and wind. The compounding piece happens on the ground, where water that has nowhere to go adds to water that was already there. The April 13th through 17th outbreak was a crisis that arrived and ended. NOAA's models show it was Pulse 1. The full sequence spans roughly 16 days, from the first tornado warnings on April 13th to the third wave arriving around April 28th and 29th. The corridor it covers stretches from eastern Kansas to western Tennessee, a distance wider than the entire state of Texas from east to west. Every home, farm, road, and water system in that corridor is being asked to absorb 3 storm pulses without a recovery window. The infrastructure wasn't designed for that loading. The rivers running through that corridor were at or near flood stage when the second pulse was issued. NOAA's weeks 3 and 4 outlook was published before Thursday's storms even form. That publication date matters because it means the connection between the events isn't hindsight, it was forward-looking. NOAA CPC saw the pattern signal, ran its computer model forecasts, and put the above-normal rainfall flag in print. The flag was public before Thursday's front began interacting with Gulf moisture. The corridor sits on 3 major river systems. The Arkansas River drains parts of Oklahoma and Arkansas. The Red River drains parts of Oklahoma, Texas, Arkansas, and Louisiana. The Mississippi River collects runoff from the entire basin. Each of those rivers has tributaries that are currently elevated. Each of those rivers feeds communities downstream. Little Rock sits on the Arkansas River, Shreveport sits near the Red River, Memphis sits on the Mississippi. Each of those cities is inside the Friday threat zone. Each of those cities is also downstream of counties that received rainfall during the April event. The downstream effect is still working through the system. For a homeowner in Memphis, the Mississippi River's level is tracked by the NWS Lower Mississippi River Forecast Center. The Forecast Center issues river stage forecasts based on upstream rainfall, snowmelt, and tributary inflow. When the upstream rainfall changes, the forecast updates. The Thursday and Friday rainfall will push the forecast upward. The April 28th and 29th rainfall will push it further. In a multipulse sequence, the return to baseline doesn't happen. The rivers stay elevated through the pauses. The next event arrives on elevated rivers. The river response accumulates. The pattern's end date isn't confirmed. The weeks 3 and 4 outlook carries a probabilistic signal, not a fixed forecast. The signal projects above normal precipitation likelihood. It doesn't project a specific rainfall total. What it does project is that the atmospheric pattern driving the pulses is expected to persist through late April. That persistence is the reason the infrastructure story matters. A flood control system designed for a single event recovery can hold through 1 pulse. It can hold through 2 pulses if the pause between them is long enough. A 3-pulse sequence with short pauses tests the design in ways the design didn't account for. The same principle applies to the NWS warning infrastructure. The warning infrastructure is staffed by meteorologists working rotating shifts. Rotating shifts are built around the assumption that event coverage is intermittent, not continuous. When a corridor is under active threat for 16 days across 3 pulses, the shift rotations and the coordination pipeline operate in a compressed mode. The Storm Prediction Center's Day 4 through 8 outlook extends beyond the Friday event and into the window where the 3rd pulse is expected. The outlook carries categorical risk designations. Categorical risk is a way of classifying how likely severe weather is, from marginal risk to moderate risk and beyond. The outlook places the corridor at elevated categorical risk through the extended window. That extended risk is the operational signal that the coverage gap missed. Local news cycles tend to move on from a story once the visible damage is assessed. The Storm Prediction Center's operational posture doesn't move on. The posture stays aligned with the pattern until the pattern shifts. Levee systems along these rivers are built to handle one peak event, then drain. They're not built to take a second hit before the first one drains. The confirmed 3rd wave arrives around April 28th and 29th. No recovery window separates it from Thursday. That missing recovery window runs straight into the design assumptions of every piece of flood control infrastructure in the corridor. Flood control systems, the levees, the retention basins, the drainage channels are engineered around something called a design storm. A design storm is a specific amount of rainfall over a specific period that the system is built to handle. The design storm is the benchmark the engineers used when they laid out the system. A levee along a river is built to hold the water back up to a specific river stage. A retention basin is built to hold a specific volume of runoff. A drainage channel is built to carry a specific flow rate. Once a design storm fills a retention basin or raises a river to the operational limit of a levee system, the system needs time to drain before it can absorb another event. That drainage time isn't optional, it's how the system resets. Without the reset, the next event arrives on a system that is already operating at or near its limit. The rivers across the Wisconsin, Minnesota, Iowa, and broader central US corridor, confirmed at or near flood stage after the April event, are in that drainage window right now. The Thursday and Friday outbreak arrives before the window closes. The NOAA Climate Prediction Center's confirmed April 28th and 29th 3rd wave arrives before the window closes again. Flood control systems are built to protect communities from severe storms. They're built for one storm at a time, with a recovery gap between them. A levee system along a river already running at 95% capacity is not protecting anyone from Thursday's rainfall. It's already doing everything it was designed to do. For a homeowner in eastern Kansas, western Missouri, or along the Mississippi tributaries in western Tennessee, the flood insurance assumption that the levee holds is based on a design standard that doesn't account for a second pulse arriving before the first one drains. The NWS Weather Prediction Center confirmed the cold front interacts with Gulf moisture late Wednesday night. Emergency management agencies in the central US operate on the assumption that after a major severe weather event, there's a recovery period. During that period, resources can be repositioned, roads can be assessed, and flood warning systems can be reset. Emergency managers use that window to move generators, water supplies, and response personnel into the zones where damage was greatest. They also use it to clear debris from storm drains, inspect bridges, and check the condition of backup power at critical facilities. A 3-pulse sequence compresses all of those recovery tasks into the gaps between active threats. The gap between the April event and the Thursday event is the window emergency managers have to reposition for the Thursday event. The gap between the Friday event and the April 28th and 29th window is the window they have to reposition for the 3rd pulse. Neither gap matches the normal post-event recovery window. The NWS forecast offices issue the watches and warnings, but the coordination with emergency managers runs through a specific role called the Warning Coordination Meteorologist. Every NWS forecast office has one. The Warning Coordination Meteorologist is the NWS official who works with county emergency managers, state emergency operations centers, and local officials to make sure warnings translate into on-the-ground response. That role works through channels that assume a post-event gap. The Warning Coordination Meteorologist calls county emergency managers before an event to confirm readiness. After the event, they debrief to identify what worked and what didn't. The debrief feeds into the readiness check for the next event. When the gap doesn't exist, the coordination pipeline runs against its own timing constraints. The debrief from the April event overlaps with the readiness check for Thursday. The debrief from Thursday will overlap with the readiness check for Friday. The debrief from Friday will overlap with the readiness check for the April 28th and 29th window. That overlap isn't a failure of the system, it's the system operating outside its designed rhythm. The rhythm assumes intermittent events. The reality is a continuous sequence. The April 13th through 17th event produced confirmed damage across Wisconsin, Minnesota, and Iowa. NWS La Crosse's 26 warning day generated a workload that post-event assessment teams are still working through. The post-event assessment is the process by which forecasters and damage survey teams determine the strength of each confirmed tornado using the enhanced Fujita scale and document the path, width, and duration of each event. That damage hasn't been fully assessed. Thursday's storms arrive on top of unassessed damage. That means communities responding to Thursday's event are still working through cleanup from the prior event while preparing for the new one. Debris that hasn't been cleared becomes a projectile hazard during the next round of damaging winds. For a homeowner in a flood-insured property, the insurance is priced against the design storm. The flood maps used by the National Flood Insurance Program reflect the design standards of the protecting infrastructure. When the infrastructure is operating outside its design envelope, the risk the homeowner is carrying isn't captured in the flood map. That's a gap the homeowner doesn't see. The flood map shows a zone. The zone is based on the assumption that the levee, the channel, and the basin are operating within their design. In a 3-pulse sequence, the assumption doesn't hold for the duration of the sequence. The coordination pipeline works. It's designed to work. What it's not designed to do is run continuously across a 16-day window with 3 major pulses. For the homeowner, the operational reality of the NWS system is invisible under normal conditions. Under compounding conditions, the reality becomes visible in the form of stretched warning lead times, delayed post-event damage surveys, and longer response windows for emergency managers. The warnings still go out, the damage surveys still happen, the response still reaches the affected communities. The speed of each step is where the compression shows up. The confirmed April 28th and 29th third wave arrives before any of the affected river systems are projected to return to normal operational levels. Those river systems sit directly below a corridor of moving air that most people never think about. The warm, moist air pushing north from the Gulf of Mexico into the Thursday threat zone doesn't originate in the Gulf. It originates from a moisture transport corridor that begins over the tropical Atlantic. The air crosses the Gulf and funnels northward through a geographic channel between the Rocky Mountains and the Appalachians. The low-level jet carried Gulf moisture north at up to 60 miles per hour during the April 13th through 17th event. It's forecast to reactivate overnight Wednesday. The moisture it delivers will hit soil that can't absorb a single additional drop. Meteorologists track this channel as the low-level jet stream. The low-level jet is a river of air roughly a mile above the surface. It carries Gulf moisture north at speeds up to 60 miles per hour overnight. During daylight hours, the surface friction and mixing slow the jet. After sunset, the surface layer cools, the friction drops, and the jet accelerates. That acceleration is why so many severe weather outbreaks in the central US intensify overnight. The low-level jet delivers moisture in pulses that peak during the hours after sundown. The pulses feed the storm complex forming along the frontal boundary. The complex grows through the night and produces its peak activity in the pre-dawn window. During the April 13th through 17th event, the low-level jet was confirmed active and feeding the storm complex. NWS forecasters tracked its activation in real time, using wind profile data from upper air observations. The jet's activation aligned with the intensification of the storm cells over Wisconsin, Minnesota, and Iowa. The same low-level jet is forecast to reactivate ahead of Thursday's cold front. The Weather Prediction Center's confirmation of the front's overnight arrival is tied to the jet's activation cycle. The front meets the Gulf moisture after the jet has accelerated, and the collision happens during the window when the atmospheric setup is at its most unstable. The moisture the jet carries will arrive on top of soils already at what forecasters call field capacity. Field capacity is the point where soil cannot absorb any more water. Once field capacity is reached, every additional raindrop becomes runoff. The rivers confirmed at or near flood stage after April 13th through 17th sit directly below the low-level jet's northern endpoint. The April 28th and 29th system arrives on basins that won't have drained from Thursday. NOAA's Climate Prediction Center flagged the April 28th and 29th moisture convergence in its weeks 3 and 4 outlook before Thursday's storms even form. That document names the Southern Plains, the Tennessee Valley, and the Lower Mississippi Valley, the same corridor already confirmed at or near flood stage. The above-normal precipitation signal in that outlook isn't a local forecast. It reflects the persistent activation of the moisture corridor that feeds the entire sequence. When the low-level jet is active on a schedule tied to the frontal boundary's position, The moisture delivery continues through multiple cycles. The corridor reloads each time the jet accelerates overnight. The viewer assumes the moisture driving Thursday's storms is a regional weather feature, Gulf air moving north. It's a transport corridor that reactivates on a schedule tied to the position of the frontal boundary, not to local conditions. That corridor moves moisture at up to 60 miles per hour through a channel roughly 400 miles wide, wider than the driving distance from Chicago to St. Louis, running continuously through the night. For residents in the Arklatex corridor, western Tennessee, and the lower Mississippi Valley, the ground is already at the point where it can't absorb anything. The low-level jet doesn't need to deliver a historic rainfall total to cause flooding. It only needs to deliver any rainfall at all. The April 28th and 29th system features the same frontal boundary alignment that produced the training storms on April 13th through 17th. The convergence risk for April 28th and 29th is that the moisture corridor aligns simultaneously with a second stalled frontal boundary. That alignment could replicate the training storm mechanism that drove the 4-inch localized totals on April 13th through 17th. This time, the ground it falls on has zero remaining absorption capacity. The river forecast centers use the gauge data and projected rainfall to produce river stage forecasts. When the projected rainfall changes, the forecast updates. The forecast for the Arkansas, the Red, and the Mississippi are currently running with assumptions that include the upcoming Thursday and Friday rainfall. The April 28th and 29th event, if it develops, will push those forecasts further. For a homeowner in Little Rock watching the Arkansas River rise, the forecast isn't abstract. It's a number on a page that projects where the river will be in 24 hours, 48 hours, and 72 hours. The number incorporates upstream rainfall. The Thursday rainfall will show up in that number. The Friday rainfall will show up after that. The April 28th and 29th rainfall, if it arrives, will show up on top of everything else. That means the corridor is functioning like a paved surface from a drainage standpoint, at least as far as the top layer of soil is concerned. Water hits the surface and moves. It doesn't soak in. The tributaries receive it within hours. The main rivers receive it within a day. The jet's forecast activation for Thursday night is already in the Weather Prediction Center's document. The jet's potential activation for the April 28th and 29th window is inside the NOAA CPC Weeks 3 and 4 outlook. Both activations are on the record. The April event showed the combination. Thursday is forecast to show it again. The April 28th and 29th window is flagged for a third appearance. The NOAA CPC outlook extends beyond April 28th and 29th to the end of the month. The above-normal precipitation signal continues through that window. That means the moisture transport isn't expected to shut off after the third pulse. It's expected to keep running. For the river forecast centers, the forward-looking assumption is that the basins will continue to receive above-normal rainfall through the end of April. The forecast for normal levels isn't in the near-term window. The river systems are projected to stay elevated until the atmospheric pattern shifts. That shift depends on a change in the large-scale pressure pattern overhead. Right now, that pattern is locked in a position that keeps the frontal boundaries sitting over the central US. Until it moves, the corridor stays in the reload cycle. NOAA's Climate Prediction Center doesn't commit to a specific date for that shift. The outlook projects probabilities across the weeks 3 and 4 window. When the probabilities tilt back toward normal, the pattern is expected to be loosening. The current outlook doesn't show that tilt inside April. For the viewer in the corridor, the timeline is what the outlook shows, not what the news cycle suggests. The timeline runs through Thursday, through Friday, through the April 28th and 29th window, and beyond. Each event in that timeline arrives on a basin that hasn't drained. Each event contributes to the next one's baseline. The coordination between the Storm Prediction Center, the Weather Prediction Center, the Climate Prediction Center, and the local NWS offices is built to handle this. The forecast updates come through on a regular cycle. The outlooks are revised as the models update. The river stage forecasts shift with the rainfall projections. What isn't built to handle this is the corridor itself. The rivers are reaching limits they don't reset quickly. The soils are at field capacity. The infrastructure was designed for single events. The atmospheric pattern is running a sequence the design didn't anticipate. The Arkansas River forecast from the NWS Lower Mississippi River Forecast Center updates Thursday morning. It will include Wednesday night's rainfall. Zero absorption capacity means the rainfall from Thursday and Friday becomes runoff immediately, and the runoff interacts with systems the viewer depends on every day. The power grid serving the central U.S. corridor is managed by the Southwest Power Pool. The Southwest Power Pool covers Kansas, Oklahoma, Missouri, Arkansas, Louisiana, and parts of neighboring states. The grid operator runs transmission lines across open terrain. There's no natural windbreak across most of the southern plains. The transmission towers stand in the open, and the lines between them stretch across farmland, range, and floodplain. On open terrain, wind hits the infrastructure without anything to slow it down. The Storm Prediction Center's Thursday and Friday outlook confirms damaging winds as one of the three hazards. Damaging winds don't have to be tornado force to take down transmission infrastructure. Straight-line winds above 58 miles per hour, confirmed as a hazard in the outlook, are sufficient to down lines across the open plains. Straight-line winds are the winds that come with the leading edge of a thunderstorm, driven by the storm's downdraft. A downdraft is the column of air descending out of the storm, and when it hits the ground, it spreads outward. The spread can carry winds above 58 miles per hour across many miles of terrain. A downed line on already saturated ground creates a water and electricity interaction risk. Electricity travels through water. Saturated ground holds water near the surface. A live line touching saturated ground energizes the surrounding area until the line is shut off by the grid operator. The municipal water systems serving Little Rock, Shreveport, and Memphis draw from river sources. River systems confirmed at or near flood stage carry elevated sediment loads and contamination loads. Sediment is the mud and debris suspended in the water. Contamination is the chemical and biological material carried by runoff from the surrounding land. Water treatment plants are built to handle a normal range of sediment and contamination. When the load rises above that normal range, the plant's treatment capacity is stressed. The plant doesn't stop delivering water. It has to work harder to produce drinkable water at the outlet. For a 65-year-old American in Little Rock, Shreveport, or Memphis, a water treatment disruption during a severe weather event arrives at the same moment road access to an alternate water source may be cut by flooding. The two failures compound. A boil water notice and a closed bridge at the same time is a different situation than either one alone. Pharmacies in flood-affected corridors close during active severe weather. They also close during road access disruptions. A pharmacy that closes during Thursday's event may not reopen before Friday's event if the roads serving it are flooded or blocked by downed lines. The central U.S. corridor cities confirmed in the Friday threat zone, Little Rock, Shreveport, and Memphis, all sit within reach of the same river systems running above normal right now. The three-pulse sequence means that if a road closes during Thursday's event, it may not reopen before Friday's event adds additional water to the same system, and if the April 28th and 29th window develops as flagged, the road may stay closed longer. Little Rock, Shreveport, and Memphis all sit on river systems confirmed above normal right now. The viewer assumes that severe weather affects outdoor property, trees, roofs, vehicles. The confirmed hazards in the SPC outlook include straight-line winds above 58 miles per hour across open plains terrain where the power grid has no natural protection. The Southwest Power Pool's transmission lines run through the same Kansas-Oklahoma-Arkansas corridor, sitting under Thursday's threat. A line going down in that zone doesn't affect one neighborhood. It affects the regional grid segment serving multiple cities simultaneously. For a 65-year-old American in Little Rock, Shreveport, or Memphis who depends on electrically powered medical equipment, a CPAP machine for sleep apnea, a home oxygen concentrator, a powered wheelchair, a regional grid disruption during a compound flood event isn't a temporary inconvenience. It's a medical decision that has to be made with no road access to a backup power source. The Southwest Power Pool's public grid resilience reports document ongoing work, but above-ground transmission segments across Kansas, Oklahoma, and Arkansas remain exposed to straight-line wind damage. Grid hardening is the term utilities use for upgrades that make transmission infrastructure more resilient. Hardening includes burying lines underground, building stronger towers, and installing automated switches that isolate damaged sections. Hardening programs are expensive and slow to implement across thousands of miles of transmission corridor. The Southwest Power Pool has documented its grid resilience work in its public reports, but the open terrain segments across Kansas, Oklahoma, and Arkansas remain largely above ground. For a homeowner with a home oxygen concentrator, the grid dependency is direct. The concentrator runs on wall power. If the wall power goes out, the concentrator stops. Most home concentrators are backed up by a short-duration battery or a small tank of medical oxygen. The backup isn't designed for a multi-day outage. A multi-day outage during a compound flood event is the scenario the three-pulse sequence introduces. If Thursday's storms take down a transmission line and the repair crew can't reach the damaged section because the road is flooded, the outage extends. If Friday's storms bring additional damage to the same corridor, the outage extends further. The repair timeline depends on road access, crew safety, and parts availability. The utilities response process starts with damage assessment. Crews drive the affected corridor, identify the downed lines, and plan the repair sequence. On flooded roads, the assessment can't happen. The crews wait until the water recedes. The recession depends on the river systems returning toward normal. The rivers aren't projected to return to normal before April 28th and 29th. For the homeowner, the waiting period is the piece that matters. A 6-hour outage is a manageable event. A 72-hour outage during a severe weather sequence is a different situation. The home oxygen user has to decide whether to shelter in place with battery backup, move to a family member's location with power, or seek shelter at a medical facility. Moving to an alternate location requires road access. During a compound flood event, road access is uncertain. The interstate highways are typically the last to close, but secondary roads, the roads that connect the interstate to the neighborhood, close earlier. A family member 20 minutes away by normal road may be 2 hours away on a detour. A hospital 15 miles away may be unreachable if the connecting bridge is over a flooded tributary. The decision to move or shelter is the personal piece of the story. The grid operator, the water utility, the pharmacy, and the road authority are all institutions operating their systems. The decision to move a family member who depends on powered medical equipment is a family decision. That decision is made in the hours before the event, not during it. The Storm Prediction Center's outlook doesn't tell the viewer when to move. It tells the viewer the severity and geography of the threat. The local NWS office's watches and warnings sharpen the timing. The local emergency manager's evacuation notices or shelter-in-place guidance finalize it. For a 65-year-old American in the Friday threat zone, the decision chain runs from the outlook down to the local notice. The outlook says the threat is real. The NWS warning, when it comes, says the storm is imminent. The local notice, if one is issued, says what action to take. Between those three layers, the time available to move is measured in hours, not days. In a compound event, the time can compress further. The viewer has to be aware of all three layers at once. Cell phone coverage during severe weather events depends on cell tower functionality. Cell towers depend on grid power and backup batteries. During extended outages, the batteries drain. Cell coverage becomes intermittent. The wireless emergency alert system sends warnings to cell phones in the affected area. The alerts are issued by the NWS and the local emergency manager. During a cell tower outage, the alerts don't reach phones in the coverage gap. The viewer's awareness of the warning depends on having a phone with signal at the moment the warning is sent. Battery-powered NOAA weather radio is the backup the NWS recommends. The radio receives warnings directly from the NWS broadcast and doesn't depend on cell infrastructure. For a homeowner in the corridor, the radio is the second layer of warning coverage. In a compound event with grid instability, the radio may be the primary layer. The pharmacy access issue runs parallel. Prescription refills during a multi-day sequence depend on either pharmacy openings or prior refill planning. The viewer who has a full refill heading into Thursday is in a different situation than the viewer who was planning to refill on Friday. The refill planning is a pre-event decision. The pharmacy's operational status is a during-event reality. The water utility's public communication runs through local news, official social media, and direct customer notices. A boil water notice or a water use restriction is communicated through those channels. During a grid outage, the channels that depend on power or internet may be unavailable. NOAA weather radio doesn't carry utility notices. The viewer has to check multiple sources. Each of these systems, the grid, the water, the roads, the pharmacies, the cell network, the warning infrastructure, is designed to work under normal conditions. Each one has a failure mode under extreme conditions. The compound event sequence stresses each one in turn. The sequence isn't built to produce cascading failure, but the geometry of 3 pulses with no recovery window creates the conditions where cascading failure becomes possible. The 3-pulse sequence ends around April 28th and 29th. NWS, Topeka's county-level tornado watch for eastern Kansas, goes into effect the moment the Storm Prediction Center's threshold is met. That watch is the viewer's first confirmed signal. Everything after it moves fast. The river systems in the corridor are not projected to return to normal levels before that date. The viewer assumes that once the Storm Prediction Center places an area under a severe weather outlook, The NWS warning system will give them adequate time to respond. In a preconditioned atmosphere, it won't. The normal watch-to-warning gap can compress to under 30 minutes when instability is already elevated. For a 65-year-old in Little Rock, Shreveport, or Memphis who needs time to reach a shelter or make a call, 30 minutes isn't the 90-minute window they may remember from past events. What's not confirmed: the exact intensity of Thursday's and Friday's storms. The SPC Day 4 through 8 outlook carries a categorical risk designation, not a specific intensity forecast. Categorical risk is a classification that tells you severe weather is likely. It doesn't tell you which counties will see which tornado strength, or how many individual storm cells will develop. Whether the April 28th and 29th system replicates the training storm mechanism from April 13th through 17th is also not confirmed. It's a risk flagged by the frontal boundary alignment. The alignment is visible in the models. The actual development depends on how the boundary behaves when it arrives. That distinction between confirmed and flagged is the honest accounting of the operational data. The Storm Prediction Center is careful about the line between those two categories. The agency publishes what's confirmed and labels the rest with probability ranges. When the agency uses categorical language, the viewer should read the category and the label carefully. The NWS issues specific watches and warnings for each county as events approach. A watch means conditions are right for severe weather to form. A warning means it's forming now or already on the ground. That compression is the operational risk the outlook doesn't spell out in plain terms. The outlook names the threat. The compression changes how much time the viewer has to act on it. Those questions aren't abstract. They're the same questions emergency managers ask before every event. The difference is that during a 3-pulse sequence, the answers change between pulses. The supplies deplete. The roads change status. The medication shelf clock runs down. The NOAA Climate Prediction Center's above-normal precipitation signal extends through the end of April. That signal was in the weeks 3 and 4 outlook before Thursday's storms formed. It remains in the outlook now. It sets the expectation for the corridor through the rest of the month. What the signal doesn't do is promise a specific event. It states that the probability of above-normal rainfall is elevated. The specific timing, amount, and location of each rainfall event come from the shorter-range forecasts. The combination of long-range signal and short-range forecasts is how the operational picture is assembled. The news cycle framed the April event as a closed chapter. The operational data framed it as Pulse 1. Thursday and Friday are Pulse 2. The April 28th and 29th window is the flagged third pulse. The above-normal precipitation signal through the end of April is the backdrop that makes all 3 pulses consistent with the same pattern. For the central US corridor, the next 10 days are inside a pattern that hasn't finished. The rivers are inside a drainage window that hasn't closed. The soil is inside a saturation state that hasn't lifted. The infrastructure is inside an operational posture that assumes a recovery window that isn't arriving. None of those facts predict a specific outcome. They describe the conditions the corridor is operating inside of. The outcome depends on how the pulses arrive, how the infrastructure holds, how quickly the emergency response adjusts, and how well the individual homeowners and caretakers read the timeline. The NOAA Climate Prediction Center's above-normal precipitation signal for the Southern Plains, Tennessee Valley, and Lower Mississippi Valley runs through the end of April, and the river systems in that corridor have no confirmed recovery window before it expires.